So we are seeing number of, so an ALP, we are writing an ALP to find number of ones, that means bits in an 8-bit number stored in internal RAM location 30H and store the result in internal RAM location 31H. This is what we are going to do. So remember, here there is only one number, so no need of using pointers or array. This is not array because only single number. Within that number we have to count number of bits, that means as 1, number of bits as 1. So a number will have 8 bits, that each bit you have to check whether it is 1 or 0. So you can easily do what? Through rotate through carry instruction, you can take each bit one at a time to carry and check whether it is 1 or 0. So this is what we are supposed to do. So let us code that question first. So you have a number at internal RAM location 30H. So rotating is possible only through accumulator, so take it to A. So from 30H internal RAM location, take that number to A. Now what you have to do is, you have to rotate 8 times because 8 bits are there. Each time you rotate and check whether it is 1 or 0. So we have to keep track of 8 time rotation. So I will keep a count, move R2 comma hash 8 times we have to do. So 08H. Initially, before starts counting, we assume that number of ones is 0. So move R0 or R1, anything you can use because here there is no pointer used. So R1, you are assuming that count of ones is in R1. Initially, it is 0, 0. Okay. This is what you are supposed to do. So question is done now and answer initialization also done. Now we will start doing the rotation. So but it should be done through carry. Either I can do RLCA or RRCA. 8 times you have to do. Doesn't matter you use RLCA or RRCA. Somehow one bit at a time has to go to carry. By RLCA also it will go. RRC also it will go. Either first bit or last bit. So I may use anything. So I will use RLC. Through C you have to do, otherwise gone. You should not use RLA because it has to get to carry. So RLCA. So now one bit of accumulator has come to carry flag. Check whether it is 1 or 0. I want to count the number of ones. So we have assumed that number of ones is 0. Now it is true if 1 is not encountered. So if jump on no carry loop. So jump on no carry, that means no carry means what? Carry is 0. Carry 0 means 1 has not encountered. You can go to the next rotation. But otherwise, that means carry is there. One time we have encountered carry as 1. That means 1 has come. So you have to do INC R1. So this, after doing this, either without updating R1, that means if 1 was not encountered, it goes here. That means you can go to the next rotation if 8 times not over, or otherwise you have to increment the carry, increment R1 when the carry is there, that means it was 1, then go to the next rotation only if 8 rotations are not over. So DJNZ. So one rotation is over now. So DJNZ R2 comma back. Back is once again rotation. So here means after the last hash step. For easiness, you can remember like that. Now every time, it will count whether there is 1 or not. After 8 times it is over, your number is over. That means all the bits of number is over. So your, this R1 is carrying the count of number of ones. That has to be stored to internal RAM location 31H. So this is what the program is. So this is how you have to do. So this is the program to count the number of ones and store the number of ones in 31H. This is the program. So my question is, I have to check whether a number stored in, whether a number stored in internal RAM location 30H is even or odd. If even, store FF in 31H, or else 00 in 31H. Check whether the number in 30H is even or odd. How will you check even or odd? If the last bit is 0 means it is even. If the last bit is 1 means it is odd. So both conditions are there here. Based on even or odd, if it is even, you have to store FF in 31H, or else 00 has to be stored in 31H. This is what you are supposed to do. Now let us see the program. So here only one number, no counting and all. Remember that. So you have your number in (30H) internal RAM location 30H. 30H can be directly addressed because it's internal RAM location. So take it to A. Now I have to check whether it is even or odd. That means I have to check content in accumulator is even or odd. That means I have to check whether the last bit is 1 or 0. If the last bit is 0, even. If the last bit is 1, odd. Now my question is to move the last bit, that means you are having carry and accumulator 8 bits. So this is the governing factor. If this is 0 means even. If this is 1 means odd. That means I have to take this to carry and check. This bit has to go to carry flag and check. So what operation will do? This bit going to this carry flag. So through carry you have to do right shift or right rotate. It should be right rotation only. See, this has to come to carry, and from carry, through carry means carry has to go here and it has to go like this. So that means you have to do a right shift or right rotation. So R through carry, right rotate right through carry A. Remember, while doing right rotation through carry, not only this bit come to carry, this carry affected this accumulator because one bit from carry corrupts accumulator. It changes the value of accumulator. So you remember, we have lost actual number in accumulator, but it is present in 30. Don't worry about that. So we are not losing number, but only losing number in accumulator because carry came and corrupted this accumulator content. but number is in 30. So remember, number has gone now, but it is in 30. Accumulator, from accumulator the number is corrupted, but it is in 30. Now by right shift what I have done, this bit has come to carry. Check what is this bit. So since we have to do operations based on whether it is even or odd, two operations are required. So I don't have to think whether I have to write JNC or JC, anything I can write, based accordingly I have to do. So if I have done JNC, I have tried a loop. JNC means no carry. No carry means carry is 0. Carry is 0 means last bit was 0. Last bit was 0 means it is even number. So you have to, if it is even number, you have to do what? You have to save or store. You have to store in 31H FF. So since first number is F, 0 FF you have to write. Now come to this condition. This condition is opposite condition of this. Here it is no carry, that means 0. Here it is carry is 1. Carry is 1 means it is odd number. Odd number means you have to save to 30 or store to 31H zero zero H. 00H. Now remember this, we are not going back from this. It should not, if I don't write anything here, both conditions will come to the same thing. Actually, if I don't break here, after doing 00, next step, if move 31H comma hash FF is executed, every time your result will be FF. So here one condition, after that I have to stop, terminate this program, because once odd number is encountered, it should not go to even numbers condition. So based on odd and even both conditions are there, means between them you have to write S jump. You can give a stop. That stop means your program is over. Now you can write an operation called NOP. NOP means no operation. That means over, terminated that instruction. This is what you are supposed to do. Remember this point, very very important. Till now we were doing only based on even number doing something, and odd number we were not doing any operation. So if based on one condition only one thing has to be done, means this problem won't be there. But here you see, based on even number also we have to take an action, based on odd number also we have to take an action. So based on the condition we have to take two conditions, means we have to do two conditions, means it means, like example, if it is even, you have to store FF to 31. If it is odd, 00 to 31, based on even as well as odd, both conditions we are doing something. So in between them, an S jump stop going to NOP. NOP means no operation should be done. This is what you are supposed to do.